All right, so LVL, I'm going to spend 2 seconds talking about LVL itself so you understand what it is. LVL, as I mentioned before, is about peeling veneers off a log. A log is put in a great big lathe and it spins at a great rate of knots with an incredibly sharp knife, which could be 2.4 metres long, and these veneers are peeled off. The veneers themselves are dried and graded so that when the various recipes of LVL are conceived, we know what grades of veneer can go into that recipe, what grades of glue go into that recipe, and they're drawn from that. They apply the glue to the veneer through a skirt of glue which drops down onto the product itself as it moves through a line. It goes through a great big press where it is then pressed up into what we call a billet. It's a big slab of timber. It is continuous, it is endlessly long. At the end of the process we chop it, otherwise it hits the end of the shed. In our particular production, the billet is 1.2 metres wide, in a range of thicknesses from 35 mil to 75. Come and speak to me later if you want to know more about that. We cut it at 13.2 metres in order to optimise it from a transport perspective. I think we can get to about 17.5. If we cut a hole in the end of the shed, we put a couple of trolleys, it ends up into the ocean and we can float it around the country. All right, so the billets themselves are made, and that's a massive stack of billets. I think in that case they're 75 mil thick and they're 13.2 metres long. And then you get the end product of LVL. Now from that, you can then make a whole range of things. It can be a planar element as a mass timber floor, wall or roof. It can be as a column, a mass timber column, block laminated to make a large section, or a beam, or you can cut it up into a stud to act as a standard stud and plate or a lintel. All right, so part of my role within Wesbeam is to take the learnings that have been on my journey from Greg and others and start to apply them to a real situation. What you're looking at here is a small exemplar project to talk about some of the uses of using timber in a mass application, in this case LVL. So columns, and you can see by the use of the red and blue how that block lamination might work to make a column out of one of these billet sections. So if the design determines that the column needs to be 600 by 400 millimetres, for example, then you can build up layers of LVL. And because it's being made in this plate format, you can then increase some sections of that build up to higher lengths than the other and create the opportunity to have a mortise and tenon, if you like, junction, which allows and speaks to how you can start to connect these buildings. So having the elements is one thing, but having the connections is another. You can also make a beam, so you can see the same concept applied to the beam, and that chamfered section is simply a beam that's been cut so that people can actually see the layers. That of course would project across and intersect with the column in the real world. You can make a mass floor out of LVL, and this is where you block laminate LVL together, and you can in turn also block laminate other materials. And at the moment I'm working with another company here in Australia to look at block laminating CLT and LVL together to get even a longer span than some of the ones that Greg was talking about. And we're talking 9+ metres in a mass floor at the moment. And of course you can make a mass wall out of LVL as well if you want to. In this instance, it's actually a hybrid mass and light frame wall, which could be used as a dividing wall for acoustic purposes. But this is a part of the journey that we're on at the moment to start help educate the market about what's possible to make LVL, in this case, into mass elements. So, this is the family of elements that I've been developing, if you like, codifying for Wesbeam to share with the industry at large. These elements we don't make, so let's get that out front right now. Wesbeam makes LVL and we bring a lot of smarts to the discussion. These elements are for further up the food chain or up the supply chain, which we like to think that we can partner with and assist with. So of course we've got all the standard things that we've been hearing about earlier today. Columns, beams, floors and walls. All of them can become mass elements. So let's look through some of the column options. In this case, a box. So this is just a snapshot of a document that we will be releasing later on in the year, talking about typical sizes. Now, I believe that there are two areas that the industry at large needs to be aware of. There's the commodification of standardised formats, And then there is the bespoke elements. Now, the fabricating sector in this country, I think, has got a long journey in front of it, but an incredibly bright journey, because some amazing examples out of Europe are showing us the way. But it's the fabricating sector that's going to start taking products like these and applying them to buildings. Now, I believe if you take a standardised building, say an office building with a 9x9 grid, typically you're going to have pretty common size column sizes, pretty common beam sizes. I think every time that somebody wants one of those, they should be able to go to a guidebook or go to the internet, find out who's manufacturing those, what the order of magnitude of cost is, what the performance is going to be, and choose which one of those they're going to select. We shouldn't have to make that from scratch every time. So these are about providing a range of standardised sizes. You can effectively say, I've taken some of the ideas that we worked through on this guide in my early days at UTAS and are now trying to apply them in this situation. Similarly with the mass column, you can block laminate the elements up to make a larger section in a range of sizes and lengths. Now, I'm not saying these are the lengths that typically you could are being manufactured, because Wesbeam's perspective is not about us moving into the prefabrication space. It's about empowering the next sector up in the industry to be able to do this and partnering with them. We're coming up with this sort of term that we're calling the compliance package. And each compliance package is going to be different depending on who you're working with. So these standardised formats I'm talking about here, my role is to work with individual prefabricators and builders, if they're looking to move down the supply chain, to be able to develop a bespoke compliance package according to what their aspirations are, what their market is. So the standardised sizes you see here are just examples. They will vary depending on what people want to make and what market they want to make them for. The same applies from columns straight across into boxes. Those box formats are typical lengths I think the market would be able to use, into the mass beam sections as well. You can see a range of sizes on there, which the market may choose to adopt. Floors, you can have a box section, which we call a box, which is being known as a cassette floor, or you can go to a mass section, and each of those are going to have their sweet spots, if you like, about where to apply them. Frames, nothing new here. People have been making frames for a long time now, but I think it's an important conversation to have, because it's not just about mass sections. Mass sections may be used for a particular building application, but frames are going to still be involved, because we still need to divide those spaces up. They may be structural, they may not. The design team are going to be part of that, determining what's efficient. And of course, you can have them as mass walls as well. You can actually rotate your billet, your E-slab as we call it, on its edge, and it can take load straight down the grains in its strongest axis. You saw this picture a little bit earlier on. About a month ago, I was on a WoodSolutions tour to Europe, and I visited this building that we saw the pictures of before. And there we have those, in this case, beach LVL columns and beams, prefabricated, and doing a fantastic job. And in my opinion, they look fantastic. Just out of interest, if anybody recognises that chap touching the wall, that's Tony. Tony's the factory manager at XLAM. So that gives you an idea about where Wesbeam and XLAM are looking to go into the future, where we've got complementary products, not competing products, that can build up what the market itself is likely to need. The 15 story, Christoph mentioned earlier on, this is it. This was literally taken 3 or 4 weeks ago. So this here is a concrete building which is going up next to the timber, prefabricated timber concrete hybrid. They both started around the same time. So this gives you a rough order of magnitude about the speed that is being developed in a more established prefabricated timber, mass timber context. So the core was put up, if you look at the building beyond, and they've only got 2 or 3 more levels than that building we topped out. Because they don't need to support the concrete through the curing stage, the lower levels have already been closed, so the timber's being kept dry, and they're beginning the fit out on the lower levels on that. Meanwhile, the concrete building next to it is still stuck waiting for concrete to cure, and there's nothing we can do to speed that process up. this particular project, and you might recognise that chap there, Christoph and Gregory, is actually a graduate of your university. He came over to Tasmania, did, what was it actually he was doing? Something with retropeeling, yep. He is now the project manager for this building, which is being built in Switzerland, and he's demonstrating to me some of the elements that have gone into this project. LVL columns and beams, in this case, beach LVL columns and beams, and that project has got 2 more levels to be completed. But if you have a look, this image here, I'm not really game to press this button. Oh, there we go, I've got it. That there is a plate which connects up on each level, which allows them to make micro adjustments to the height of the building in case there's been any settling or creeping through the process. So they're getting really smart with the way they build these structures, and this is an off-the-shelf product, I believe. So that gives you an idea about some of the possibilities in mass timber. Now, this is my second last slide. This is the slide that tells you about some of the companies that Wesbeam is working with at the moment to go through the innovation process through to ex-innovation. And if you look across there, you'll see there are representatives across the board. There are builders there are prefabricators there are architects, engineers, developers, and of course other mass timber companies. So this is an ongoing discussion, and it's a broad-based discussion. At the end of the day, we're all in this together, I believe. It's not actually me against you or product against product. It's about finding the correct solution and mapping a pathway with our colleagues. That's my last slide. Thank you very much.